Okay, what I'm going to do in this video is create, oops, that's the wrong pen, let's try this one, create an app service which will be running an ASP.NET application, and the ASP.NET application talks to a database at the back end, and this is an Azure SQL DB. So this is PAS, and this is PAS. Now the way that people would normally do this is they would put all of this into one resource group to define the application. That would normally be one resource group, but what I'm doing is no entry sign, because I've already got the database, I've got this already created, and I've actually already got the app service created, and they're actually separated, and they're separated for some other reasons, for other demos that I've done. I did a separate demo for each of those separately. So the reason for me telling you this is because in here, in this ASP.NET application, I've got some code which is vulnerable to SQL injection attacks. So what I want to do in this demo is put a WAF here, so that anybody who sends requests, let's get a request, do that in blue, shall we? Let's get an HTTP request here. Anybody who takes a request and passes it into the ASP.NET application that comes in here, it's going to go through all this stuff. It's going to be subjected to a SQL vulnerability injection attack, and I could attack that database. So what I want to do is to have it go through the WAF first of all, and for the WAF to do some jiggery-pokery poking around inside the HTTP and sort of say, whoa, this is an injection attack, and send back to the user a forbidden message. Forbidden, you can't do that. So we need the WAF in place in order to be able to do that. So that's what we're going to do. We're going to build that WAF, and we're going to attach it to an existing ASP.NET application which is vulnerable to SQL injection and is already set up to talk to a back-end SQL database. Okay, so first of all, let's have a quick look at the application. If I go in here and I go to my resource groups, where have they gone? All resources. That should be up there, really. Just there, I think. I've got a resource group called SQL Vulnerable, something like that. We'll find it. RG SQL Injection App Insights. I'll tell you what we'll do. We'll go to the database. We'll go to the app service, because I can't remember which resource group I put it in. SQL Vulnerable App Service, and that is in a resource group called RG SQL Vulnerable App Service. RG for resource group. RG-SQL Vulnerable App Service. Okay, so if I go here, this should give me an overview page which will show me the URL, and I should be able to go there and we'll see this insecure website, and we'll actually do an attack on it just to prove that it is vulnerable. So up here, look, this is the URL up in the top right hand corner where I'm wiggling the mouse. So if I click that, it'll take me to the site. Because the site hasn't been hit for a little while, it's going to take a few minutes for IIS to spin up and for all the different ASP.NET classes to spin up, but there we go. So it says, we know how important security is to our customers, and here at PIM, Planketronics in Securitas Maxima, we're proud to go against the tide and have made our system as insecure as we can. So let's try a SQL injection attack. So I've set this up to be as insecure as we can possibly imagine it to be. So I've got a username there of Planky. I've got a password, and there's the password. Look, you would never do this in real life, but we're an insecure site. Do a login, and what that does is it queries the database and sees if it can find a username record of Planky and a password record of my password, and if it does, then it prints out from another database the orders that I've put, my credit card details and the orders that I've put into this system. Okay, so what I could do is I could put an attack in here. I think if I do that, it shows me all 1 equals 1. So this is a SQL injection attack where it's basically going to, this quote here finishes off the quote from the previous bit of the query and says, you know, whatever the query is, select star from something where username equals Planky, but then we put that quote there to finish off that piece, and then we say, or 1 equals 1, and then we put a comment delimiter there to say everything after this is just commentary. It's of no consequence. So this is a really common SQL injection attack. So if 1 equals 1, well, it does equal 1, doesn't it? 1 does equal 1, which means that we'll get a return of true. And what the application does is it looks for anything that's true, and says if we get the return value of true, then we consider the user to be logged in. So let's see what happens if we do that. In fact, what I should do first is log out of the existing account and then log in. And you can see it's just printed out all the different user details for all the different users. So we didn't, in fact, I've got the password there. Let's forget about the password. Let's just put some rubbish in there. Let's log out again. Let's do this properly, shall we? Yeah, so I'll just put rubbish in here, log in, and it should find everything, because 1 and 1 does equal 1, and therefore it returns true, and therefore it does what it said it would do, which is to return the orders for the users. Which users are we talking about? Well, we're talking for all of the users because we've returned 1 for all the records. Okay, so that's the insecure website, and we want to protect against things like that. So what we want to do is we want to put a WAF in the front of that site. So that means we've got to create the WAF. So let's go and do that. Now, let me get back on the whiteboard. Whiteboard. Let's get rid of that one there. Create a new one. So what we're going to do is WAFs. The WAF I'm going to use is the Azure App Gateway brackets WAF. So you can use the App Gateway to do things like load balancing, sticky sessions, SSL termination, all that kind of stuff. We're going to use it as a WAF, and there is a mode that you can put it in. You'll see the I'll set the property to WAF, and you'll see me do that in the demo when I get into the actual portal and start, configuring things. So we're going to use an App Gateway. Now, an App Gateway, here, let's draw one approximately there. An App Gateway, normally the way you would use an App Gateway in WAF mode is that you would attach it to a virtual network. Here's a virtual network. That virtual network, you would put it into its own subnet. So here's a subnet, let's call it WAF. That's the WAF subnet. There would be a default subnet, and we would normally have a special type of an environment over here called an application service environment. It's almost like a little miniature version of the app service parts of Azure. And this boundary here is your boundary. It's got it doesn't connect to anything of the rest of the Azure infrastructure. So in here you've got some front end services which do things like the load balancing for you, all that kind of stuff. And you've got your actual application which you may have spread across. Let's just say you've spread it across 1, 2, 3, 4, 5, 6, 7, 8 servers as an example. So that's your app service environment, and you would normally attach that to this virtual network. So that if we had, should we draw the internet on here? Here's the internet. So if we've got a user on the internet just here, and the user has a laptop, then what this WAF does is it has a public IP address, a PIP public IP address, which has a DNS name, which will be the name of the site. And what would normally happen is the user would generate an HTTP request. Let's do one of those here. Got to draw this all in one sort of go. There's the HTTP request, and they would send that HTTP request across the internet. It would hit the pip. The pip would transport it into the WAF. The WAF would do all the deep packet inspection, make sure that that doesn't have a SQL injection attack in it, or a cross-site scripting attack, or any other attack. And then it would route it onto this virtual network, and it would be eventually routed across through this connection into this environment, through the front ends, and into one of these servers, which would process the request. That's how you normally do it. So the thing about normally doing it is that there is normally an association between the WAF and this thing called the VNet, because the VNet is normally part of the transaction. But we're not going to use ASE. This is going to become a no entry sign, because we're not going to be using app service environment. It's a very expensive way of doing things, and it's relevant in some cases, but not to the small website. So for small websites, you probably wouldn't do that because of the complexity and the expense of doing it. So let's draw another diagram. Another one. So what we're going to do, we are going to build. We've already got our app service. We know it's got some ASP code, and we know we can put a username and a password, a U and a P for username and password. And we've got a login button. And we know that if we do that, that's going to cause a query to occur on an Azure SQL DB, which consists of a thing. I'm going to call it a server in quotes, because it's actually not. There's not a separate server. It's a service which looks like a server, and you can type a connection string and it responds in the same way, but it's not really a server. And at the back end, we've got a database. We've got we've got one database, and we've got two tables. One's called users, and one is called orders. And so what happens with this application is that you when you log in, it takes the username, it takes the password, it adds them onto a query, it passes that into this server. The server then queries the username table to see whether those things are in there, and if it does, then it pulls all the orders out of the system, passes it through to here, and then we display them all on the home page, as you saw just a few moments ago. But that's not protecting against the against bad people doing bad things. So this has got a public IP address, and it's got a DNS name as well, something@something.com. That's something@azurewebsites.net. In fact, I think it's SQLvulnerable.azurewebsites.net. We'll have a look at the name in a minute. So that's on the internet. So this is the internet. Look, let's draw that in blue. The pip is on the internet. And what we're going to do is we're going to build separately a WAF. That's going to live on a VNet, because remember what I said, there's association normally between a WAF and a VNet. We're not going to actually use that VNet, but we're going to build it onto it because that's a requirement. And this has a public IP address, a pip. And that also has a DNS name. It has a bit of a more long and complicated default DNS name, but you can customize that DNS name. So now let's have a look at what will happen if we send some data. So here's our user. Here is their computing device. And let's generate a red, let's do a green HTTP request. So here's an HTTP request. Let's imagine that's what an HTTP request looks like. So what they're going to do is they're going to type in the URL of the pip, the URL of the DNS which is associated with the pip that is part of the WAF. So that is going to be routed down here into this pip. It's going to go inside the WAF. The WAF is going to do all the software inspection of this HTTP request and determine whether or not it's an attack. If it's an attack, it will return a response that says forbidden. If it's not an attack, then it's going to pass it on to the application service. Now, if there was an ASE, the thing we talked about earlier, it would come out through this route onto the VNet and be routed into the ASE. But that's not the case. What's going to happen this time is this request is going to come from the user. It's going to go through this pip. It's going to be transported into the WAF. The WAF is going to inspect it. Let's imagine it's clean. It's then going to send it out of the same public IP address and send it into this public IP address where it's now trusted, and we know that it's not going to be a SQL injection attack, and so this is going to result in just a normal login as expected. Now I'm sure you can spot a few problems with this. Like one of them might be, what if this user was, whoops, I don't know why that happened. I think I can just pick it up like that. Yeah. What happens if this user, when they created this HTTP request, what if they knew the address of the pip, or what if they were to do a scan and find the address of the pip of the application service? And what if they were to just therefore put their SQL injection attack into this packet and route it this way? Then they will have just completely bypassed all the WAF security that you set up. And so obviously one of the things that we need to do is we need to put some kind of, on this pip, we need to put an IP restriction. And the sort of thing we'll do is we'll deny everybody ********, but we'll allow whatever that IP address is there. We'll allow that to go through. So nothing can get through, nothing can go through here unless it came from, let's do it in green, unless it came from this WAF and was previously inspected and came out of this pip and got routed into that one. So that's what we're going to do. So the first job is to create the VNet. This VNet in red, which I'm just going to highlight here. This get it in red. This VNet that I'm highlighting in red, we need to create that VNet in order to create a subnet that the WAF is going to go onto, and we need to create the WAF as well. And then we got a load of configuration to do of the WAF. So let's have a go at that in the portal, shall we? Let's close that down. We don't need that anymore. So we've got our app service here, and we're going to create a virtual network. So we go to virtual networks, add, and the name of this virtual network can be VNet SQL injection. What did I call? I called it VNet SQL injection. That'll do. I'm sure we'll remember that. It's giving me a suggested address space 172.20.0.0/16. So what that means is all addresses, the first 16 bits, so 172 is the first octet, consists of 8 bits. 20 is the next octet, that consists of another 8 bits, so that's 16 bits. So we load bits in from the left-hand side until we get to 16, and we say all addresses in the 172.20 range, everything from 172.20.0.0 through to 172.20.255.255, all of those addresses are the address space. So we'll just take their suggestion. What they basically do is they look at all the other VNets you've got and they say, if these were ever to be configured together, by default that doesn't happen, but if these were ever to be configured together, would we have overlapping IP addresses? And in this case we wouldn't, because it's chosen a good option for us. Okay, then this is the subscription I'm going to use. So this is a subscription that Microsoft gives me to do demos. Then the resource group, so we want to find that SQL injection, we don't want to create a new one, we want to find the existing one that has got, I think it's that one there, SQL Vulnerable App Service. That was the one, wasn't it? Well, I think this was all in North Europe, so yeah, the resource group is in North Europe, so we'll put that in North Europe. There's a subnet called default, and that has got that range there. Notice that is /24. So that means we know we're going to live in the 172.20 address space, and then the next 8 bits, 16 through to 24, gives us another 8 bits, is that .0 there. That could be anything between .0 and .255. So we're in the .0 subnet, and it's called the default subnet. Okay, do we want any DDoS protection? Let's have the basic DDoS protection. Do we want service endpoints or firewall? We won't have that, and we'll hit create. Okay, that's gone pretty quickly. So we're going to go and have a look at that resource. That's the virtual network, and if we go to subnets, we should see a default subnet on there, but we want an extra subnet. We want one for the WAF, because we can't use the default subnet for the WAF. So we click subnet, add subnet, that's plus subnet, and we'll call this one WAF because it's the WAF subnet, and this one is going to be in 172.20.1.0/24. The previous one was in 172.20.0.0/24. This one is in 172.20.1.0/24. So we're in the second subnet. First one was the 0th subnet. This is the first subnet, so it's the second one in the list because we count from 0. We won't bother with a network security group or a route table or service endpoints or subnet delegation. So we'll just say OK to that. And that should now go away and add another subnet. And in a minute we get, yeah, there we go. We've got a WAF subnet. You can actually see it's easier to see the numbers when they're lined up again. So the two 172s line up, the two 20s line up, and then we've got a .0 over here for the first subnet default. And we've got a .1 for the subnet over here. Okay, so now we've got our subnet. Next thing to do, that is something onto which we can build our WAF. The reason I build the subnet as a separate exercise outside of building the WAF, because when you build the WAF, one of the questions it asks you is, do you want a subnet? But the problem you've got is that you need to have a separate subnet for the WAF to go onto, and it doesn't give you the opportunity to create the subnet, only the VNet. Okay, so let's go to application, what are they called? All services. If I type WAF in here, it'll show us the Microsoft WAF. Application gateways, that includes a WAF. Now most of this is, kind of like, it just helps you along. You can see I've already got one called WAF, Gloucestershire WAF. So let's add a new one in here. And we go through the basic configuration now. So what is the name of this one going to be? I'm going to call this one SQL Vulnerable WAF. So the tiers are how much money you pay and how many features you get. WAF v2 might be a good idea. It gives you things like certain things can be customized. I think you can have a custom IP. I think you can have a static IP address if you use the v2. I've actually not used the v2, so because I've not done it, I'm going to stick with WAF, with this WAF. Just because I know how to do this, and I'm not going to come across any questions I don't know about. Okay, how many instances of this WAF do we want? Now, 2 is a good idea, because if one of them fails, then the other one will continue to work. But in the interest of keeping the costs down for my boss, who gives me my demo subscription, I'm going to put 1. But you would probably put 2. You might even put 3 or 4, depending on the size of your estate. The SKU size, I think a little bit of a clue here. Look, we've got medium and large. Where's small? Ooh, I wonder if that's coming in the future. So let's go for medium. It's a reasonable size. It gives us a certain level of performance. If we had a really big website, we might want to move it up to a large. Okay, so we're going to use my internal subscription that I use for my demos. The resource group that we're going to use for this is going to be the same one, the SQL Vulnerable one, RG SQL Vulnerable App Service. Put it in North Europe, which is actually in Dublin. What does it say? Your virtual network and public IP address must be in the same location as your gateway. By location, it means the same data center or the same region, which is North Europe. And it is. We put everything into North Europe so far. So we click OK. And that goes away and provisions that. I think. Oh no, we got some more configuration to do before it actually does the provisioning. And the provisioning takes about 10, maybe 20 minutes. But let's have a look at this. Look, so we've got to choose a virtual network on which this is going to live. We're not going to use this virtual network, but it lives on a virtual network. So what do? We don't create new. Bit odd that we've got no results there. That says to me that the virtual network is in a different location to where this WAF is going, but I'm pretty sure that I put everything into North Europe. So let's go and have a look at the virtual networks. Yeah, let's leave those edits. Bit of troubleshooting as we go along here. What did I call it? VNet SQL injection. It says it's in North Europe. So we've got it's in North Europe. Does that mean that I've put the VNet is in North Europe? That's the VNet I'm looking at. I was in the middle of building the WAF. So let's go back. Let's just hit the back button and get back to that page. If it goes that far, there's the virtual networks. There's the application gateway. Right, so let's do this again. I'm going to call this WAF SQL injection. Standard tier, the WAF tier, instance count of 1, medium size. That resource group is going to be, I wonder if the resource group, have I got a couple of these? I've got RG SQL Vulnerable App Service. Have I got another one that sounds a little bit like that? Because I've done a few of these demos in the past. Oh, look, there's the App Insights one there. I wonder if that's the one that's in North Europe. I'm now going to have to go and check that resource group, aren't I? So let's go back to resource groups, SQL Vulnerable App Service. SQL Vulnerable App Service. Oh, that's in UK West. That's the wrong one. Right, so that means I've got to put everything in UK West. Oh, isn't this annoying? Now, I did have another one. I think that works. See, why did I put that in UK West? I think I will do this properly, so I'm going to create another virtual network. In fact, what I probably should do is delete the one I've already created because it's kind of not going to be used. What did I call it? It's VNet SQL injection. So let's delete that one. See, look at this. Look, all the value you're getting. Troubleshooting as we go along. Delete. I mean, you should really... I should really have written all of this out and had all the configuration before I even started doing this, but I'm a little bit impatient and I'm not doing that. I wouldn't do this in a genuine production environment. This is just a demo, so we're kind of safe here. So now let's go virtual networks. Add. VNet SQL injection, or was it SQL vulnerable, wasn't it? SQL vulnerable. I think that was the one. I'm getting mixed up already. It's come up with a suggestion because I deleted the previous one. It's come up with exactly the same address space, same subscription, resource group, right? RG SQL vulnerable app service. Location North Europe, yes. Subnet is default. All of that is okay. Basic. Service endpoints are disabled. Firewalls disabled. Hit create. So it goes away and creates the virtual network. This is just a software-defined network. It lives in a kind of an advanced version of Hyper-V, which is known as the Azure Hypervisor. That's been designed specifically to work in the very large data centers with thousands, hundreds of thousands of physical and virtual servers. Right, so has that done that? Let's refresh this. VNet SQL vulnerable. Right, okay, and it's in North Europe, so that's looking good so far. Let's go to our WAF. which we go to all services. Let's type WAF. Oh no, sorry, I've got to go back to the VNet and create another subnet. SQL vulnerable. Subnet. There's the default, so let's add one for the WAF. So call it rather imaginatively the WAF subnet. It's the .1.0 network. I don't need NSGs, I don't need root table, don't need service endpoints, don't need subnet delegation. So I can just click go ahead on that. Okay, that's good. Now we can go to all resources, no, to all services. We can find the WAF. There it is, application gateways, which includes the WAF. So we're not going to do any of that West Europe stuff here. We're sticking with North Europe. So we go add basics, things like the name of the WAF, which I'm going to call WAF SQL vulnerable. Standard tier, which we're changing to WAF. The SKU size is going to, instance count is going to be 1 to keep the cost down. SKU size medium, that's the lowest one. Use my subscription resource group. We'll use that SQL RG SQL vulnerable app service. Location is North Europe this time. It's looking a bit better, isn't it? Now this is where we find out, because in settings the first thing is subnet. So I'm hoping I can see a subnet here now when I do this. Fingers crossed. I got loads of them. VNet SQL vulnerable, that's the one. That's got nothing to do with it. That's got nothing to do with it. These are all previous ones for demos I've done in the past. So that's the one. We've been successful. The subnet we're going to use is going to be the WAF subnet. So that's that one there. We created it earlier, do you remember? And then we've got the front-end IP configuration to do. So let me just get the whiteboard up again. I think I'll delete that one. Let's delete that. Let's delete that one. Let's delete that. No. That's my rowing plan for a rowing race I've got next weekend. Let's delete that one. Delete, and let's create a new whiteboard. And let's go back into the portal to remind me what it was I was going to show. I was going to show our front-end IP configuration. So we've got our VNet down here. We know that we've got some subnets on it. We've got the default subnet, and we've got the WAF subnet. And the WAF subnet is connected to the WAF. And the WAF has a public IP address, which is connected. And this is called the front end. And you can see why it's called the front end, because that's where the data comes in the first place. So we're going to go through the process of configuring this front end. Let's do that. Go back here. So it says front end IP configuration. Do I want a public or a private IP address? So if it was a private IP address, that would exist internally inside a network that nobody on the public internet could see, but we're not doing that. We want this to be on the public internet. Do I already have an existing IP address that I'd like to use, or do I want to create a brand new one? And it actually gives me a suggested name by using some of the previous configuration that I've put in there. I'm actually going to call it IP WAF SQL. I always like to have the type at the front. IP WAF SQL vulnerable. And then I can configure it. So basic, if I had gone for a type of version 2 of the WAF, I could have had a type of IP address which was static and never changes. But we're going to be using names. We're going to be using DNS names anyway, so I think we don't really need to worry about that. 4-minute timeout. DNS name label. So it's going to be something.northeurope.cloudapp.azure.com. So I'm going to call this one SQL vulnerable. And it gives me a little green tick. So it's going. So this front end. Let's go back here. The DNS name of this bit at the front here, the front end, is going to be sqlvulnerable.northeurope.cloudapp.azure.com. I think that's what it says on the end there. Can't really see it, can you? So we're going to go with the dynamic address. That means it's an address. It's a bit like a DHCP address. It lasts for 168 years. How did they come to 168 years? If you work it out in seconds, I think it comes to 4 billion, something like that, which is a computer number, isn't it? Right, we're not going to be using HTTP2. Don't want to worry about that. We've got our web application firewall, which we will enable. We're going to put it into prevention mode. If you don't put it into prevention mode, what happens is you end up with a load of attacks and you end up with a log that says you've been attacked. Well, that's not the point of a firewall. Or it probably could be in the case of finding out if you're being attacked and troubleshooting and that kind of thing. But when it's a production system, you want to put it into prevention. So that's that. We're going to have to configure another listener for port 443 a bit later on. But at the moment, we've got port HTTP. I think if I do HTTPS, it might come up with that configure. Yes, it does. I need a certificate, and I haven't got one yet, so I think I'll do that later. I'll add the listener configuration for HTTPS later on. So let's stick with HTTP for the moment. I'm going to go on port 80. HTTP 2.0, we're not going to use that. So we're going to disable that. Web app firewall. Status is enabled and it's in prevention mode, so we click OK. So then we get a little summary, and then when I click OK, this is the bit that's going to take somewhere between 10 and 20 minutes. So I might have some chocolate and some coffee in while that's happening. And off we go. If you ever do this, whenever you're doing anything, it says deployment in progress, submitting deployment. You see this little bell here. If you click that, it gives you some information. So you get some idea about what's going on. It gives you things like how long it took. So you can see previous configurations that I've done here. And then this is the latest one. And the clue is this little twinkling bar. Is it twillipsis, I think people call them. The twinkling ellipses. Twillipsis. Okay, so let's leave that. I'm going to go and make a coffee. I'll probably edit this gap out afterwards. Got the coffee, but it's still going. I've got a chocolate bar. You know what would be good? Would be, they must know the average time that it takes for a WAF or a VNet or a VM or a cognitive service or whatever. They must know kind of, approximately the amount of time it takes to deploy one of those. So it should give you a little message that says, this will take approximately 10 minutes. Because I know that it takes 2 hours to create an app service environment, and you sort of, when you're doing it, you sort of get to that point, you click the go button, and you're thinking, is this still going? Is this still going? You think it's going to be a few minutes, and it's 2 hours. I mean, it would be nice because you'd have the opportunity to then, I don't know, go shopping or do the garden or, do something else while you're waiting. So we're just waiting for this to happen now, and I think this is somewhere between 10 and 20 minutes. I feel as though I should be telling you jokes or something. Showing you something else, maybe. Maybe something else I could show you. I know what I'm going to do. I'm going to show you my... I'm doing a race in the rowing boat in a single scull. What's a single scull? That's the first question, isn't it? Can we find a picture of a single skull? A single skull. Yeah, these are single skulls. Let's have a look at, where does it say images? Images. So they're boats for one person and they've got 2 oars, one on the left hand side, one on the right hand side. There you go, that's a single skull. So I race in these boats, and ooh, look at that! Like, that guy really doesn't want to fall in, does he? Because look at the ice. I've fallen in the winter, and it's not much fun. And these boats are very narrow and very, very, very wobbly. They don't look all that wobbly when you see them at the Olympics, but I can guarantee you they are absolutely. When on really cold days, you're in fear of going in at any moment. So I'm going to race one of these at Abingdon on the 14th of April, and I made a little plan. I've very carefully studied the course because I've never rowed the course before, so you can end up stuck in bushes and things like that. And this is my plan. Look, let's change the scope on this. So this is the river. Let's change the magnification a little bit. So this is the end of the course. The river flows in this direction. It's not usual to actually race against the flow, but that's what I'm going to do. So the start is down here. I'm going to race against the flow. It starts on a bend. That's a number of red buoys. You've got to stay on the inside of those red buoys. You're not allowed to. You're not even allowed to have your oars overlap them. And then there's a little thing here in the river, a little sign that says there's a little tributary opposite. Watch out for boats coming out of there. And I have watched some videos of people doing this race, and I know it's 60 strokes between there and this big bush. And then I know it's 50 strokes between that big bush and the place where the pylon cables overtake. And that is just on that bend there. So I know when I see the cables overhead, I know I've got to start bending at that point. See, the trouble is with these boats is that you row, you're facing backwards. So you have to continuously look over your shoulder. And every time you take a look over your shoulder, you lose 10th, 20th of a second, 10th or a 5th of a second maybe. Just because you're not concentrating on what you're doing. And then I get around this bend, a little hook, and I get to here, and I know there's about 100 strokes to the end then. It's 1.85 kilometers, pretty short race. And I've got some idea of the pace I'll do. So if you're used to the rowing machine, you'll be used to these numbers. 2:28 is on a rowing machine, that's very, very slow, but in a boat against the stream, that's pretty well. I think it's pretty quick. I can do 144.3 for a 2K on the rowing machine. But I'm down to 2:28 when I'm at this race because boats are a different thing. You can't fall off a rowing machine into the water, but you can fall off a boat into the water. So you have to, your technique has to be considerably more precise, and that causes you to be slower. And actually, the ergo is not a direct correlation to a boat. It's fairly close to an 8, but an 8 has got 8 people in it, so 8 people rowing goes quite a lot quicker. So that's my plan. Let's hope that's filled in enough time for that other job to have finished. It's done it. Yes. Oh, isn't that good? Right. Okay. So we've got our gateway done. If we refresh this display, it should show, I've got one, it should show another one below it. There we go, WAF SQL vulnerable. Its public IP address is going to be 40.85.80.10. So let's go back to our diagram. Not that one, but this one. So the front end here is going to be, I've forgotten the number now. Let's go back and have a look. 40.85, I think if I just do that, can I paste that in here? doesn't let you paste. I think I've got to do, is there something like text? Can I do text? Oh well, I can't remember how you do it. So it's 40.85.20.10. So that's the public IP address. And remember, that is a public IP address which accepts data in and pushes data out. So it's a dual purpose thing. It's bi-directional. It's a bit like having a network card as a router with two subnets, but only one network card with one physical connection to the network. But it's got routes between multiple IP addresses on the same card. So you can think of this as being a NIC. I suppose you could say from there up to there, it's a NIC with two IP addresses. Right. Actually just got one IP address, but it's taking data in and sending data out. Right, let's go back. Let's get to our WAF. And then it's a case of going down through these properties. So the overview will show us overview information about this WAF, and it says 40.85.80.10. I think I wrote something else there, didn't I? 40.85.80.10. No, I've put 20 there, look. 80.10. Go back. And its default name is sqlvulnerable.northeurope.cloudapp.azure.com. If I click this, put it into here, you'll see SQL vulnerable, that's the name of the application, .northeurope, that's the location, .cloudapp.azure.com. So that's its DNS name. It's in the WAF tier. It's using the right subscription. It's in North Europe, so everything's looking good. Obviously, there's going to be no logging yet because we've not actually used it. It's not even fully configured yet. So the activity log is probably just going to say it's been created and nothing else. It's initializing the activity log as well now. Yeah, create or update an application gateway. We won't bother about all these things here. So we'll get into the settings. So the configuration. So it's a WAF. The SKU size is medium, and the instance count, we've got one instance, but we can go up to 75 on this particular tier. If we were to go from the medium tier to the large tier, I think we'll see that this goes up to, oh, I thought it went up to 100. Okay, well, we're sticking with medium anyway to keep the costs down. HTTP2 we know is disabled because hardly anything uses HTTP2. Okay, so let's go to the web application firewall, the WAF. So let's configure things. So standard or WAF, we've gone for WAF. We're going to enable the status. The firewall mode is prevention, because you can actually see it working when you do prevention. If you send some bad data to it, it sends you back a message saying forbidden. These are exclusions, so there might be certain rules that you want to exclude. You'd have to know what they are, and you could say, you know, if this field is equal to this, then don't do it. The maximum request body of a HTTP packet it will inspect is 128K, and the maximum, if you send a file, it's also going to inspect that and look for attacks, and it'll do that up to 100 megabytes. You can change these numbers, but you can't go. I think 128 and 100 is the maximum of both. So now in rules, I think that just says that this WAF protects against the 10 of the OWASP family of attacks. So SQL injection is in there, but that's not just an attack. That is one of a family of attacks which are defined by this OWASP organization. So we're not going to go for any advanced rule configuration, because if we do that, then it allows us to actually sort of discount certain attacks and enforce other attacks, but I don't want that. I want everything to be inspected. Go back here. So we haven't made any changes to these pages because the save button hasn't become enabled, so that looks okay. Right, so in the same way that we had a front end pool, we've got a back end pool. So in this case, we've got an app gateway backend pool with one rule associated. Let's have a look at it. So what we have is the idea of a target. So let's go back to our diagram. I'm going to redraw that because it's a little bit scrappy. Let me do this. So we've got our VNet. We've got on that our WAF. We've got an IP address. I've actually forgotten what it was I was going to say, so let me go back here and see what it was. It was, oh yeah, it was about backend pool. So when the data is coming into this system and is going to be inspected by the software that looks at the HTTP request, that is called the front end. But remember, over here we've got an app service, and we know at the bottom of that is Windows, and above that is IIS, on the top of that is ASP.NET, and my little SQL application which is vulnerable to SQL attacks, and that's effectively got a public IP address. So we know that once it's passed the tests, then the data comes out of here, and it comes out of here and goes in to there. So when it's going in this direction, out, that's known as the back end. So on many environments, you'd have two network cards to do this. This will give you the actual physical isolation as well. But we're on the internet in any case, which is a public place to be. So that's what we mean by the back end. So let's go back here. So remove all targets from the backend pool. We don't want to do that. It says, okay, where is this backend pool going to be? Is it going to be an IP address, or is it going to be an app service? One which we already know about. Yeah, well, this should now contain a list of all the app services that I've got on my machine. And there they all are. So there's that one called SQL. The app service was called SQL Vulnerable App Service. So then I should be able to save that. Next we get to HTTP settings. So I've got a HTTP setting which is called App Gateway Backend HTTP Settings. Listens on port 80 to the HTTP protocol, and cookie-based affinity has been switched off. So if I click this and look at the detail, cookie affinity disabled, connection draining disabled, protocol just HTTP, which is going to run on port 80. We're going to have a 30-second timeout. We're not going to override any backend pool. We're going to use it for the app service, and I think that's enough. Create a probe, we don't need to worry about that. So I click save for that. And it's going to take I think this one takes like about 2 minutes. So deployment failed there, but it seems to have carried on. Let's have a look at it. So it seems as though it failed, but then it immediately succeeded afterwards. So we've just got to, oh no, sorry, let's go up here. Deployment failed. At least one resource deployment operation failed, but then it says it's saving. So let's just wait for this to finish and see what happens. Deployment to resource group, that one failed. Additional details from the underlying API that might be helpful. At least one resource deployment operation failed. Please list deployment operations for details. Please see ARM debug for usage details. ARM is the Azure Resource Manager. So something to do with the Resource Manager not being able to deploy that bit of configuration. If it fails again, we'll just try again. Because it seems to have moved straight on to the next thing. I think I'm hoping that I haven't got my SQL vulnerable and my SQL injection AI naming mixed up somewhere along the way here. What are the two most difficult things in computing? The first most difficult thing in computing is naming things. Naming variables, naming servers, naming infrastructure, coming up with names which are self-descriptive and don't require you to reference documents is really difficult to do, especially when you've got things like, you know, a WAF, they've got the WAF name, WAF timeout, all these kinds of things. And then the second thing is cache invalidate. If you've got two CPUs, each with their own cache to speed things up, and one goes away to memory, pulls into cache some data, operates on it, leaves it in cache. The next one wants to go to that memory location but doesn't realize that the data that you've just operated on is still in your cache. How does it get to know that and to be told to invalidate the operation? So that's the next biggest problem. And the third problem is off by one errors. Hopefully you just laughed, because I said the two biggest problems are naming things and cache invalidate errors. And then I said number 3 is off by one errors, proving that we were off by one. Because some things count from 1 and some things count from 0. So those are the most irritating things. But we'll see what's happened here, shall we? Let's go back and have a look. We were doing back-end pools. That rule, I think it was all okay. Yeah, no, it's set that back to IP address or FQDN. So what I wanted to do was set that to an app service and set that to a specific app service, which was my SQL vulnerable app service. And then save it. So is that what failed? Isn't it annoying that we have to wait again for that? We'll click this and we'll see its progress. Deployment in progress. If that doesn't work, I'm going to try another trick, which is to try a fully qualified domain name for the resource that we are configuring. Get past this piece of configuration and I'll change it back later. Some really good stories for these long gaps, don't you? I know what I could do. I could pass the time idly by showing you the rowing race. So it's Abingdon Springhead. This is the race. I think event information, the course. It shows the course. There we go. So we start here on this bend, go around the bend, up. Sorry, no, we don't. We start down here. We start here on this bend. We go around the bend. That's where that little post is. That tells you about stuff. Then up here, round this bend, little hooky bend just there, and then we get up to the finish, which is just there. One of the nice things they did actually on this site was they put this video here. So it's a 360-degree video of somebody rowing the course, or of a couple of ladies rowing the course. Because one of the things about rowing is when you don't know the course, I've never been on this piece of river, I've never even seen it. So when you're rowing and you've got to continuously look behind yourself, sometimes you've only got to leave it 2 or 3 strokes and you end up rowing into the bush or into a tree or into a little bay or something. And that's a little bit like in a car race, spinning off, because it's going to take you 2 or 3 minutes to recover from that. And, you know, in a sort of about a 10-minute race, that's going to be a disaster. So they did this. This is rather good. So look at this, look. There's the boat ready to set off. Off it goes. So I can actually see the course now. Of course, I'm not facing that way when I'm rowing. I'm facing where I've been. What have they done? It's a 360 video, so I can twist this round. Yeah, look at that. You can see the ladies rowing. There's 2 of them. But that one that you can see in the pink, one in front of her. You can see 2 sets of oars there going into the water. You can see all these trees going by. I can see how close I can get to them. If I come around here, we'll see this post there. Yeah, look at that. See that post just there, look. Exactly opposite that post. If I spin around quickly, that post there, exactly opposite that post, there it is. Entrance. Just there to another river, to a tributary. And then I can watch these going down, get some idea of what it should look like. As I look over my shoulder, this is the sort of thing I should be seeing, and I shouldn't be that close to these trees that I end up getting stuck in these bushes and having to back my way out of them, and you know, everybody going past, people just going past laughing. It's very embarrassing. Yeah, so isn't that pretty cool what they've done there to help people who've never rowed this course before? Of course, people who row it every week who are a member of this club can have a little big advantage because they know it intimately, but I don't. So I just thought that was rather good. Shall we see if that's finished now then? Let's go back. Deployment succeeded. Yes, right. Well, that's a bit better, isn't it? So we've got our app gateway backend pool. What do I want to do now? The backend pool is, let me just look at the configuration and see if it's actually taken it. I want to see if it's pointing at that correct app service. App service is SQL Vulnerable App Service. That's the one. So we got that right. So we can close that down. So now we go to backend pools. We've done that. HTTP settings. So we've got a setting for port 80, HTTP. What we need now is one for port 243. So a little bit of jiggery pokery is going to come in here. So if I do that, so let me close that down. Let me get that name there, because App Gateway Backend HTTP Settings is a good name for the App Gateway's Backend HTTP Settings. So if I add a new one for HTTPS, what I'm going to use is the same naming convention that they've used. So I'm going to paste that name in, only it's HTTPS, not HTTP. So I'll put an S on the end just there. Cookie-based affinity disabled, connection draining disabled, protocol HTTPS this time. And we know that the port is going to be 443 and the name is going to be the name of the URL. So how do we find the URL name? That is the same as the HTTPS, as the HTTP name, and I think I copied it in here, didn't I? What a good job I copied it in there, look. So it's going to be that. So let's copy that, go back to the thing here, put that name in there. Oh, that's a bit odd. It normally says upload a Pfx certificate. That's saying upload a CER certificate. Why is that? That's really confused me, because I did this about 3 hours ago, and it said Pfx file, because it's much easier to get a Pfx file than it is to get a CER certificate. What have they done that for? That's really irritating. Right, well, let's just go back to here. I've got some PowerShell here, which helps to create a self-signed certificate. So rather than me going to a certificate authority and getting my SSL certificate and paying $50, $150, whatever it is for it, I'm going to use a self-signed certificate. So I'm going to not only create the certificate, I'm going to digitally sign it myself. So it's kind of got a circular reference in it. Who issued the certificate? Me. Who signed the certificate? Me. So it's this stuff here. I need to change the name of the site. So if I go back here, get that site name, copy it, go back to the, in fact what I could do is find PowerShell ISE, and let's run that as an administrator. And then it's a bit easier to just get all of this, put it into the, I'll copy all of that, I'll put it into the script pane. Right, you know what's messed up on that is all the line feeds, haven't they? Something. Right, cert is new self-signed certificate minus cert store location, cert local machine, my DNS name. I'm going to change that DNS name into the one I just copied. Hoping that didn't overlap on the line. Yeah. What's gone wrong here? New self-signed certificate. I've got another new self-signed certificate. Let me just Control Z that. Let's go full screen. Right, new self-signed certificate, cert store location, local machine, DNS name is that. That's good. Next, the password equals convert to secure string. The string is word passed with $. -4 says plain text. That's good. The path is cert local machine my. Yep, that goes into the root, into the certificate store on my local machine. The cert, I'm going to pass in the cert thumbprint as well, and then that is on the long line. That should be on the next line. Export certificate cert path minus file path is going to go to temp cert SQL vuln. That'll do. And the password is whatever I assigned into that variable up there, which I think I put up here somewhere. Password equals word pass as a plain piece of plain text. So should we try all of that? Let's do all of that and see what happens. Just run all of that. Seems to have done it. So if I go to the temp file on my local hard drive, I should have that certificate. C temp cert SQL vulnerable.pfx. It's a PFX. I've got to somehow get that into a .cer because they've completely messed up. Oh, they're so irritating. That really is irritating. Let's just try and see what happens if we choose a PFX file. There's the PFX file. Invalid file type selected. Why have they done that? Why would they do that? What is the point of messing things up into the least popular certificate file format? Right, well, it has put the certificate into my local certificate store. So if I use Cert Manager, this has got nothing to do with the task at hand. This is to do with stuff around the outside of it. If I go to my local, that's the local computer, go to the local personal store, I should find that one in there somewhere. Not in there. That's a bit odd. Why is it not in there? I'm sure that PowerShell completed. And I said to put it into cert local machine my. So that's in the local machines certificate store. So if I go here, and I go to certificates, personal certificate, that is for the local computer certificate. It should be in here. I should see one with that DNS name that we created. You can see it's created the other ones that I've had. Let's just keep going down. Enterprise, intermediate, trusted, untrusted, for trusted people, test routes. I wonder if it's put it not into local machine, but I said local machine. My. So there should be. Oh! Ah, look what I've done. That's bad. I've just spotted the mistake. Let me get rid of that certificate there. Delete it. When I put the stuff into PowerShell, I didn't change the URL. So let's go back and get the proper URL. That one there. Proper URL. Copy that. Put it back into PowerShell. Put it in here. It was my fault after all. Right, then we'll just run that lot there. That's worked okay. So I've got a file called that. So now I should have, I think I've probably got to refresh this. Refresh. There it is. So if I now double click that, there is somewhere a export certificate button. Copy to file. Next. Yes, we need to export the private key. We'll just leave all of that as it is. I think I can just use the password. No, do password here. So I'm protecting the private key in it. Right, so I'm hoping now this is going to let me create it's a PFX as well. Can I do a CR? No, I can't do a CER. Oh. Oh, they've really irritated me by doing that. All that's done is mess things up. That hasn't made things any better. That's just screwed more people up. I need to convert that file into a CER. Why did they do that? Oh. I can't see how that's an improvement on the system. It just makes things worse. Convert Pfx to CER. Oh, I've got to install OpenSSL. Let's have a look at this one. Oh, puts them in PEM format. I don't want PEM format. I want CER. As you can guess, I'm very irritated with the product group for doing something so stupid. Well, I'm just going to have to somehow find something which converts a Pfx to a CER. So there's things to go the other way, but not from Pfx to CER. Try convert .pfx to .cer. OpenSSL. I'm trying to export it. The Pfx option is grayed out. Let's go back there. Where's my certificate manager gone? Certificate manager. Certificate manager. Oh, where's that gone? Right, so it's personal certificates. We know it's that one there. More actions. Let's try opening it. Right. It was only hours ago, and it's a Saturday. I can't believe they will have changed it on a Saturday. I must have made a mistake. I've never seen it say that before, though. Where are we here? Upload a CER. Select a CER certificate file. Why? Why? Have I got something in here which forces it to do that? to add. There's got to be a way to convert it. Well, there is a way to convert it, and I think I'm going to have to end up downloading OpenSSL. And is there a Windows version of OpenSSL? Do I now have to install a Linux machine and then install OpenSSL on that, and then copy the file to it and do the conversion, and then copy the file off it? I can't see why they would have done this. It just has enormously increased the inconvenience and complexity of doing this. Convert.pfx to .cer. Download and install OpenSSL. See resources. I accept that. Can you see a thing that says resources? Download and install OpenSSL. See resources. Oh, no. All of this has got nothing to do. See resources. I can't see resources anywhere. Up here. No, let's just go OpenSSL download for Windows. OpenSSL.org. OpenSSL never releases Windows-based binaries. Is that true? Let's have a look. So I've got to do all the compiling it and all that stuff. So why would they want to put me to this level of inconvenience? You don't do it in binary format, so I don't get like a setup.exe or anything like that. I bet you can do it with PowerShell. Use PowerShell to convert .pfx to .cer. Too much. Certutil. That was what's Certutil? I've used that before for something. Can't remember what. Certutil. Oh, it's part of certificate services. So I've got to install certificate services to use certutil. That's no good. Let's go back to that PowerShell there. That says export Pfx certificate. Let's see if we can export CER. There's an export certificate there. I wonder if that export. Right, I am going to export certificate minus cert. Then I'll say, and then I'm sure it wants file. Yeah, it does want file path. And we'll put it in the same place. C:\temp / cert SQL vulnerability CER.CER. And then it's going to want a password. No, it doesn't want the password. That's not good because it's been set up with a password. How can it export the private key if it's not protected? Doesn't do it. Export certificate. Well, let's just try it without the password and see what happens, shall we? Right, I'll do all this stuff. No, I'll actually got to comment that out. What's the comment delimiter in PowerShell? I've forgotten what it is. Is it oops, wrong line. Is that? No, is it that? Why has it gone on to the next line? It can't be that, can it? That's just a string. PowerShell comment delimiter. Just what's the comment delimiter? For goodness sakes, look at all of this stuff. PowerShell comments. Oh, of course it's a hash, isn't it? Oh, how did I forget that? So I'll hash that. Right. So let's do all of that. No problem. Now let's see what happens when we try and do the export. There's a password in there protecting the private key, so I can't see that's going to work. Let's see what happens. Well, it's created the file. Let's try it, shall we? Right. Go back here. Back here. Let's go and get that file. I don't think it's going to work because of the password. 443 request 40 override backend path. Use custom probe pick hostname, override hostname. See, normally it asks you for the password because the password inside that certificate there's a private key. The private key is protected by a password, and to unlock the private key we need a password. But this is a CER file, which is obviously doesn't, perhaps it doesn't even contain private key material. Oh, well, we'll see what happens. I'm not very, oh yeah, we're going to use, override the backend path, use for app service, we want to do that. I think that's all we want. Right, let's go, okay. It looks like it did it, but I don't believe it. Because how on earth could it get that private key without the password? Well, let's keep going. Front-end IP configurations. Public app gateway front-end IP. I think that is all set. I think we've already looked at this actually. Yeah, it's just got the public IP address. It doesn't actually show you the DNS name that's associated with it, but there is a DNS name associated with it. Listeners. HTTP listener. Ah, that's a bit. Can I refresh that? So I thought I just added that listener. So it didn't work. If I go there again, add a new one. Name, HTTPS, listener, app gateway front end port, new name is the name of the site, which is here. Oh, come on. That's the name. Click somewhere here to get back. Front end port new name is that. Port is 443. Protocol is HTTPS. Oh, that's looking a bit better. Right, look, certificate, Pfx file. What did we do different? I don't know what we did different. That one there. The name, same as before. The password, WordPass. Right. I think that's it. Let's click OK. Got it added in there. Okay, something was superseded. I don't really know what that means. It's still doing something at the moment. Have a look here. Saving changes to the app gateway, the WAF. I've just realised I didn't need to really bother with all of this because my little SQL vulnerable website doesn't actually use HTTPS. Although it's well to know it, because if you're going to copy what I've done here to deploy your own, then you will probably almost certainly be using HTTPS for some aspect of your site, even if it's just like WordPress site and you need to do an administrator login or something. You'd want to do that over HTTPS. I seem to remember this took about 5 minutes to do. I'll talk about rowing a bit more now, because this is the thing which absorbs me when I'm not doing computers. I'm actually not an expert rower, but I do enjoy it. I can beat a few people, but not everybody. And there's one of me. Is anybody equally finding that YouTube Studio is really slow? That was about a week and a half ago when we had that really nice weather. I didn't have to wear a vest. In fact, it was too hot to wear a vest when you're working hard. There we go. Back and see how it's getting on. Listeners still saving. Yeah, what can we talk about in the meantime? suppose I could talk about a couple of these properties here, couldn't I? That's doing that update. So we're on listeners. Let's go back to front-end IP configurations. We've got that configured for the front-end gateway. Do you remember that had its own IP address? The HTTP settings, we've got 2 listeners, one on 443, one on port 80. The back-end pools, we're going to that back-end pool address. So there's a rule associated with that, app gateway back-end pool. Then this was just about the app gateway firewall itself, about what things we'd enabled and which things we hadn't. I did see something, health probes. What are health probes? They are useful when you have, let's get the whiteboard back, shall we? Where's that gone? Whiteboard. If you've got 2 WAFs, one WAF here and one WAF, oops. You've got 2 WAFs, 2 public IP addresses connected here. You can actually set a load balancer in front of them. And the load balancer, so your HTTP requests now come into this load balancer. And the load balancer sends the data either to here or to here. What the health probes do is they regularly send an HTTP request to an address. Typically it's just /, so it would be http://mysite.com/. And as long as they get an HTTP 200 response from that, which is okay, then they know, then it'll send the probe, it'll get the response back, and it ticks it off as saying that one's okay. And then it sends the probe to this one, gets the response back, that's okay. And I think that happens every 60 seconds. So if you were to have a failure of one of these, within 60 seconds it would know that it had failed, and it could remove it from the configuration. And because this is a PaaS service, the PaaS service will find for you a new instance and it will move it in to the configuration. You'll only really find out, you might not find out that that's happened at all, or you'll probably only find out about it by seeing some entries in the event log saying that the probe failed for a number of times while the fault management was being done behind the scenes. So that's interesting, isn't it? Properties. This is, every resource in Azure just gives you this list of properties. It's kind of like a summary of everything. I think if you use the summary of these properties plus the overview tag up here, it's useful. Oh, template. Now that's worth talking about. Whenever you create anything in Azure, I'm going to use the whiteboard again. I'll do a new one of these. Whenever you create anything in Azure, let's do something really simple. Let's create a VM that's got a disk, it's got a network card, and it lives on a VNet. So you have this file, and it's full of JSON. It's called an ARM, Azure Resource Manager template, and it's broken into sections. So the first section is the version. Let me just show you. We get here, sorry, not the version, the schema. So the very first bit of the file is the schema, and that's this. So that defines the schema. If you go to that URL, you can find out about the schema. The next bit of the file is the content version. So let's draw those in, shall we? So we've got the schema, the content version, and those are really short. They're just the schema is just a number, and the content version is just a number, and the schema is a URL. But then you have some bigger sections. One's called parameters. I'll tell you about that in a minute. One's called variables. One is called resources, and the final one is called output. And the ones you're really interested in are, well, really it's this one and this one. So resources, there'll be an entry in here, there'll be a JSON entry in here for something like the VNet. And it will be VNet name, and the name will be VNet1. So that's how it knows what the name of your VNet is. It's all in this JSON file. So that every single resource, you know, so you end up with quite a lot of entries in here. Let's have a look at the one that we were playing with, and that's just for, if I go down to resources here and show you all this JSON, you can see how much of it there is. There's a lot of it. Every little tiny bit of configuration information is all held in this stuff here. But I wonder if that was the certificate that we saw back there. Public certificate data. There you go. Look at that. Look. So all that stuff is held in there. So if you take, I'm going to try and find one. Let's go to a parameter. So I've got a virtual network parameter there. It's highlighted. And the virtual network's vulnerable name is VNet SQL vulnerable. So this is the variable name, and this is its value. Well, that's its default value, and it says it's a string. It's always going to be a string. So if I was to search for this somewhere in the resources, so let's go at that, shall we? I wonder if Control F works. It does. Well, isn't that good? So there it is in the resources. So what they do is they put in virtual networks VNet SQL vulnerable name. That's the name of the variable. And then you can, up here, that one there, what was it? Virtual network VNet. Virtual network, that one there. You can change the content of that value. Why is it not? I think that's because that's still open. There we go. You can change that itself. So if we go back here, so you've got all these parameters. You've got the variable name, and then you've got the name, the value of the parameter. The variable name, the value of the parameter. And whenever your resources require a variable, you can just slot it in there. So it means you don't have to hard code. It means that the idea of hard coding this doesn't exist. What you do is you write your changes into these parameters, and then you feed the parameters into the resources. Now variables are a little bit like parameters, but they can do things like, for example, you could have one parameter which is the SQL server name, not for what we're doing at the moment, but for something else. And you could have the database name, and you could have the user ID and password. And then you might use a variable to actually take all of these things and concatenate them together into one big long thing, which you call a connection string. So you're just really taking individual parameters and doing stuff with them to make in one big thing, and then you feed that connection string into your resources. So that's what a template is. A template is parameters, variables, and resources that are going to be deployed when you deploy this template. There's another file. Let's do that in black. Another file that sits alongside this, and that is called the parameters file. So let's just say you've got a parameter here, and it's called SQL Server name. SQL Server name. If in your parameters file you have a parameter called SQL Server name, and you submit both of these files together, the main template file and the parameters file, anything that you've got in your parameters file overwrites what you've got in the parameters section of your deployment file, of your template file, your Azure Resource Manager template file. So that becomes useful. I'm going to draw another picture. So let's just say you've got one template file which has got the standardized way in which you like to deploy SQL servers, let's just say SQL servers. And then what you can have then is you can work on getting this file absolutely perfect, and you can have a bunch of different parameter files, parameter file 1, parameter file 2, parameter file 3. And let's just say this is going to go to department 1. You can have a SQL server in department 1, a SQL server in department 2, and a SQL server in department 3. So you'll send that pair to department 1 because it's parameter file 1. You'll send this pair to department 2. Get the idea there. And you'll send this pair to department 3. And what you'll end up with is exactly the same configuration. It's just things like the name of the server, the name of the user, the size of the server, all that kind of thing will be different in each department because you've used these different parameter files. Now, let me just create another whiteboard. If you think that, what you've actually got is you've got the internet. The internet is connected to an Azure data center. And when you use something like the portal that we're using, or when you use PowerShell, or when you use the CLI, or when you write your own .NET code to call the API, then there's an ARM API here, Azure Resource Manager API. And what happens is, in the portal, you say something like you want a new gateway. You send that instruction to this API, and then it talks to all the internal infrastructure inside Azure and says, right, we've got a rack over here, we've got a server on that rack, we've got a spare slot in there, we're going to target that one. We're going to take all the configuration information that you pass across as part of your portal, and then we'll build that into this. So this is the glue that keeps the actual physical infrastructure in tune with what your configuration is. So the way that you get this, the way that you use this is that with PowerShell, for example, you create the files I was just telling you about, the template and the parameters file, and you use a PowerShell command to pass those into this ARM front end, and it will then go away and do all the magic behind the scenes to make these things happen. And you don't have to use PowerShell. If I show you in the portal, where do we go to? Export template. We've got the template, we've got the parameters file. As you can see, let's just go back and have a look at that. Look, so we've got a parameter here. It's called Sites SQL Vulnerable App Service something or other. And if we go to the parameters file, we've got one called Sites SQL Vulnerable App Service name. So if we were to put a value in here other than null, that would override anything which is in the template. Meaning I could have one template and 10 different parameters files and deploy exactly the same configuration to 10 different locations, but each one of them having a different location name, different location size, different connection strings, different default databases, etc. So these are the two main things, but then you get PowerShell. So this is the PowerShell script which will deploy your template. And actually there's a lot of sort of plumbing in here, all this parameters and all this kind of stuff. But you get down here and eventually you get to this line here and it says new Azure RM resource group deployment to this resource group name, whatever the resource group name is that you specified. That's a variable there, which comes from, what's a parameter actually, which comes from up here somewhere. Param resource group name, just there. let's go down. Whatever the name of the deployment is, whatever the template file is that you're using, there's the name of the template file, and whatever the parameter file is. So that's the actual command which does stuff. The rest of all of this is just the plumbing, so that if something goes wrong, you find out what the exception is and all that kind of stuff. With .NET, same thing, but you got just some .NET code to do it, so you could put this into a tool of your own. Why they've picked Ruby to put that in here, no idea, but somebody must have been a Ruby fanatic at one stage and said, we need to have Ruby in here, but this just does the same thing, but in Ruby. So if you know Ruby, then you can write some Ruby code to deploy your parameter and your template files. Okay, has it done it? Should we go back and look? Looks, no, you've got to be careful here because you've always got to scroll up. It says it's saved the changes, so let's live in hope on that, shall we? So I think where did we get to? We got to listeners, didn't we? Then we got our 2 listeners. Did we get to rules? Rule 1, which is the basic. Let's have a look at that rule. Yeah, I got a feeling we need another rule. Let's go basic. Name. Rule 2. Following the naming convention, we'll use the HTTPS listener, the backend pool, and this will be an HTTPS settings. That is certainly different to the last time I did it. But at least we've got rules with one HTTP listener and one HTTPS listener. And we've configured the listeners above. So we've got the rules and we've got the listeners. Just got to wait for it to actually complete. Let's get this up here. Saving. And when this is done, we can actually try and see if we can get a page delivered through the WAF. I wonder if there's anything else I could tell you about while this is going on, other than rowing, or templates, or HTTP settings, or certificates. I'll just say that there's something which makes me suspicious that this isn't going to work, and it's the fact that when I created that self-signed certificate, I said to include the private key inside the certificate. It's called PKM, Private Key Material. And it's a protected resource because you don't, private key, you want to keep it private. And you normally, when you do that, you generate the self-signed certificate and you put a password on it so that somebody would need, who wanted to get access to that private key, would need to know the password. So I put a password on that certificate. When I imported it, it didn't ask me for the password when I imported it into Azure. And that makes me suspicious. And it was asking for a .cer, which I can't actually remember whether that just includes the private key material without a password to protect it. Doesn't seem very likely, but yeah, I was confused when I saw that .cer. I've never seen that before. I've only ever seen it asking for Pfx. So that's done, hasn't it? That's done. So, fingers crossed. Let's see if this works, shall we? So we're going to go here. And we should get a page. should get the SQL page. You know, my application that you've already seen. That one there. So that works. Does HTTPS work? So let's try that. HTTPS://. Now that probably is working, and the reason we've got this is because we're using an untrusted certificate. This certificate that I have placed in here was signed by me, and who am I? I'm not like, you know, Thought or who are the big certificate authority companies? It's the really big one. Forgotten the name of them. Anyway, there's a bunch of certificate authority companies that are responsible for doing sort of business checks on you before they issue you certificates. So you can actually just click here and go to the web page, and I'm hoping this will work now. So let's keep our fingers crossed. Yeah, that gets us there. So one of the ways to actually make this work a little bit better is to go into the certificate manager. Go into the certificate manager and make that little certificate that I created just for our little demo, make it into a root certificate authority. So if I go into personal certificates, oh, I've got two of them in there now. Which one is which? Oh, well, I'll tell you what I'll do. I'll just grab them both. I'll copy them and I'll put them into trusted root certificate authorities. Trusted root certificate authorities. So if I just paste them into there, paste. So then now the issuer is trusted, and the issuer is the same as the recipient, sqlvulnerable.northeurope.cloudapp.azure.com. So if I now go back to here and I do the same thing again, if I do HTTPS, let's go to a different page first of all. Let's go to ibm.com. Right, so if I now go HTTPS:// and paste the rest of the name in. No. Paste the rest of the name in from here. Here. So now I shouldn't get that, you know, somebody's trying to fool you. It should just take me straight into the HTTPS configuration of the site. And it does. You can see up here it says HTTPS certificate error. It's saying, that's going to say, this is signed. What does it say? It's not really telling you. What it should say is this certificate is signed by itself. It's a self-signed certificate. View certificate is, what's it saying? It's telling us all about the certificate. It's not telling us why it doesn't like it. Not very good, is it? Well, I can tell you the reason it doesn't like it is because that is both the subject and the issuer of the certificate. But you can see that if we were to have a proper certificate there, if we'd gone to a CA and bought one, then it would work. Now the next thing is we've got a WAF running now, so we shouldn't be able to do a SQL injection attack. So do you remember before I could put any old password in there and I could use that SQL injection syntax to attack. So I'm hoping now that this is going to fail. Yes, forbidden access is denied. So that's good, isn't it? If I go back and I put in a proper username, Planky, and a proper password, my password, and log in, that works and it prints out the credit card information. So we have protected back-end web app. Now, we still have a problem. If we go to Azure, go to the resource group which holds all this, can't remember what it's called now. Was it SQL Vulnerable RG SQL? No, it wasn't that one. I think it was just called RG. Oh, I know what to do. We'll go to the app service. click this and it'll tell us which resource group it's in up in this page here in a second. Just here. RG SQL Vulnerable App Service. Let's go to that resource group. Oh, we found... I've just done one step too many. We found the actual the app service. There it is. And that's going to have a DNS name. URL is just... Can't see my mouse. There it is. Just here, look, top right hand corner. So let's go there. Oh, that's open. Let's do a SQL injection attack. Oh no, it's still... Can you see the problem we've got now? If we go to the old URL, it still works. Let's draw a little diagram to explain that. New one. So what we've got now is we've got a WAF at the front end. It's connected to a VNet. It's got a public IP address. We know that data goes into that and comes out of that. The data that comes out of that goes to the public IP address of the web app, or as we call it, the app service. So what we need to do is put protection around this. What we want to do is deny all, but allow that IP address to send data. So we know what the IP address is. We've got that in this file here. It's that address there, so I'm going to put that in the paste buffer. Now I'm going to go to the application. App service. Right, so I'm looking for deployment center. No, it's not deployment center, it's network, sorry. I'm looking for networking. And you can see down here we've got access restrictions. I'm sure I clicked that then, didn't I? Oh, there it is. Look, configure access restrictions. Okay, so that's why we could get in, because it allows all. By default, everybody's allowed in. So we're going to add a rule, and you'll see how this works. It automatically adds a deny all. So I'm going to specify this is going to have. Let's call this WAF only. So we're only allowing the WAF to get in here. The action is to allow this WAF with a priority of, let's just say 300, IPv4, and we need to specify the IP address. So let's type that in there, and I need to do /32 because that's the only. That's going to slide the subnet mask in for the first 8 bits, the second 8 bits, the third 8 bits, and the fourth 8 bits. Give me all 32 bits is that one IP address. So I'll click that. That's going to do another. We've got to wait for this to be updated. It says it's added. No, it says it's done. That was quick, wasn't it? Most things are at least 5 minutes. Right. Okay, so now if we go back here, that's the WAF protected URL. Where's the one? That's directly onto the website, so this should fail now. When I go here, yeah, okay, so we can't get to it because we've got a protection in front of it, so we can't get to that website. The only way to get to that website is to go to the WAF. So that's this page here. If I refresh it, we should see it should work. Resubmit the form. That works. But if I do a SQL injection attack, well, I need to log out first anyway. I can't actually log out, look. Let's try again. What am I doing here? I want to go to that. So if I do that and some rubbish, that should give me denied. Forbidden, yes. Right. I'm hoping after all that that was useful. Very long. You've learned all about certificates, rowing, WAFs, app services, VNets, IP addresses, public IP addresses, how the protection works, what the interaction is between the two. It's been a good education, I think. Right, hope you enjoyed it. Talk to you later. I'm going to stop the recording now. If indeed I have a recording. In here, I think. There it is. I think function F9 stops it. Function